Now it's time to plot our data points. We've determined the scales, we've got our graph ready to go. We have to plot our points. So I'm looking for a frequency of 1,252, and I look at my vertical axis, my y-axis, and I see that 1,200 is here, and each line is 25 more, so 1225, 1250. So 1252 is just a little bit bigger than that line, probably right about there. And I look for my 1 over my wavelength is 3.57. I know 3.5 is here. The next line over is 3.55 and then 3.6. So it's going to be right down the middle there. And now I look for the point where those two lines intersect. And I plot my point where they intersect. So there's my first point, and now I'm ready to plot my second point. A frequency of 1,600.5 is basically right here, 1,600. And on my x-axis, I'm looking for 4.55. Well, 4.5 is here, and 4.55 is one line on one grid line to the right of that. So now I look for the point where those two intersect. I'll put a point there. That's my second data point. And now I'm ready to plot my third data point. So I'm looking for a frequency of 2,000. That occurs right there. And on my x-axis, 5.56. Here's 5.5. Here's 5.55. So just a little to the right of that spot right there. So I'll put my third data point right there. If I look at these three data points, it looks like they fall on a straight line. So I want to get my ruler out and try to draw a nice straight line through them. I kind of like this line. It sort of splits the difference. I have 2 points that are above the line, one that's below. I think this is a pretty good fit. You don't want all your points to be above the line or all below. You want to try and split the difference. Now we want to find the slope of this line, because the slope of this line is going to equal the speed of our sound wave. And our slope is equal to the change in y over the change in x. So we need to find a couple of points here that'll help us find the slope. I want to pick points that are sort of extreme. One up here near the end, and the other one down here near the other end of my line. I'm looking for a place where that red line that I drew with my ruler intersects the grid lines very nicely. And I think I found one. So I can find the x and y values at that point. If I trace back to my x-axis, I have 5.45. And if I trace back to my y-axis, I have 1,950 hertz. So the x value here is 5.45, and the y value is 1,950 hertz. Now I need a second point, and then I can find the slope. I think I'm going to use the point where it hits the x-axis. That looks like it's intersecting very nicely at the intersection of my grid lines. So the x value there is 3.45, and the y value is 1,200. X value of 3.45 and the y value of 1,200. The slope is the change in y over the change in x, and my y value changes from 1,200 hertz up to 1950 hertz, 1,950. So I take the difference between those two, and I divide by the change in x. X changes from 3.45 up to 5.45. So I get 750 divided by 2, which is 375. And the units work out to be meters per second. 375 meters per second for the speed of sound.